Crude oil is the lifeblood of our modern world. It powers our cars, heats our homes, and is a key ingredient in countless products we use daily. We extract it from deep within the earth, often from miles below the surface, using advanced drilling techniques. This thick, black liquid is a complex mixture of hydrocarbons, which are organic compounds made up of hydrogen and carbon atoms. Unfortunately, it often contains an unwelcome guest sulfur. This element can be found in varying amounts in different crude oil sources. Sulfur is a naturally occurring element, often found in the Earth's crust and in volcanic regions. It finds its way into crude oil during its formation over millions of years, as organic matter decomposes and transforms under heat and pressure. While seemingly insignificant, sulfur poses a significant problem. Even small amounts can cause major issues in refining and usage. When burned in engines, it transforms into sulfur dioxide, a harmful gas that contributes to air pollution and acid rain. Sulfur dioxide is a major air pollutant, affecting both human health and the environment. The presence of sulfur in fuels necessitates costly refining processes. These processes are designed to remove or reduce the sulfur content to acceptable levels. These processes aim to remove or reduce sulfur content, ensuring that the fuels we use are cleaner and less harmful to the environment. This ensures compliance with increasingly stringent environmental regulations, which are put in place to protect our planet and public health. The quest for cleaner fuel has driven innovation in the field of desulfurization techniques. Researchers and engineers are constantly developing new methods to make the process more efficient and effective. The release of sulfur dioxide into the atmosphere has dire consequences. It contributes significantly to acid rain. Acid rain wreaks havoc on ecosystems, acidifying lakes and harming plant and animal life. Buildings and monuments also suffer from its corrosive effects. Furthermore, sulfur dioxide is a respiratory irritant. It contributes to smog and poses health risks, especially for individuals with respiratory problems. The environmental and health implications of sulfur emissions have spurred a global effort to reduce them. Traditional desulfurization methods typically involve chemical processes. These processes use high temperatures and pressures. They aim to break down sulfur compounds and remove them from the fuel. While effective, these methods have drawbacks. They are energy-intensive and require large-scale infrastructure. This results in significant operating costs. Moreover, some methods produce hazardous byproducts, necessitating further treatment and disposal. The search for more efficient and environmentally friendly alternatives is ongoing. Section 4. A New Hope Gamma irradiation enters the ring. Gamma irradiation is a process that utilizes high-energy gamma rays. These rays are a powerful form of electromagnetic radiation, capable of penetrating deep into materials. These rays are a form of electromagnetic radiation. They have a very short wavelength and high frequency, which gives them their penetrating power. They can penetrate matter and interact with molecules, including those containing sulfur. This interaction can break down complex sulfur compounds. This interaction can alter the chemical structure of sulfur compounds, making them easier to remove. By breaking down these compounds, gamma irradiation simplifies the desulfurization process. Unlike traditional methods, gamma irradiation does not require high temperatures or pressures. This means that the process can be carried out under more moderate conditions. This makes it a potentially more energy-efficient and cost-effective approach. Refineries can save on energy costs and reduce their carbon footprint. Moreover, it doesn't involve the use of additional chemicals, minimizing the risk of hazardous byproducts. This makes gamma irradiation a safer and more environmentally friendly option for oil processing. Section 5. Arabian Nights, Cleaner Skies, Insights from Recent Research. Recent research has focused on the application of gamma irradiation to desulfurize Arabian crude oils. This innovative approach aims to address the environmental challenges posed by high sulfur content in these oils. These oils are known for their high sulfur content, making them a prime candidate for testing this technology. The high sulfur levels contribute to air pollution when the oil is burned, so reducing sulfur content is crucial. Initial findings show significant promise. The gamma irradiation process has been able to break down sulfur compounds effectively, leading to cleaner burning fuel. Studies have demonstrated a notable reduction in sulfur content after gamma irradiation. This reduction is not only beneficial for the environment, but also enhances the quality of the oil. This indicates the effectiveness of the process in breaking down sulfur compounds. The chemical reactions triggered by gamma irradiation are key to this transformation. Moreover, analysis using techniques like Fourier transform infrared spectroscopy, or FTIR, has provided valuable insights into the chemical changes occurring within the oil. These insights are crucial for further refining the process and ensuring its efficiency. Welcome to For Science Salah Lotfy channel. Today we explore groundbreaking research in the field of radiation chemistry, focusing on the role of gamma irradiation and sulfur transfer within Arabian crude oil distillate fractions. Let's dive into the details of this innovative study and its significance in advancing energy science. This research, titled Sulfur Transfer in the Distillate Fractions of Arabian Crude Oils Under Gamma Irradiation, was published in the journal Radiation Physics and Chemistry, Volume 134, 2017, pages 83 to 88. It provides valuable insights into how gamma irradiation can influence sulfur distribution in crude oil, a critical step for reducing environmental pollution from fossil fuels. The study was received on September 19, 2016, revised on December 28, 2016, accepted on January 31, 2017, and made available online on February 1, 2017. The research was conducted by a team of esteemed scientists from Saudi Arabia and Egypt. First, we have Professor Dr. Ahmed Basfar, a renowned expert currently serving as a professor of nuclear and radiation engineering in the Mechanical Engineering Department, College of Engineering, King Saud University, Riyadh, Saudi Arabia. He is also affiliated with King Abdullah City for Atomic and Renewable Energy. Next, Professor Dr. Yasser Soliman, from the Radiation Protection and Dosimetry Department at the National Center for Radiation Research and Technology, part of the Egyptian Atomic Energy Authority in Cairo, Egypt. Finally, Professor Dr. Turki Alkhuraiji, who is associated with King Abdulaziz City for Science and Technology at the Nuclear Science Research Institute and the National Center for Irradiation Technology in Riyadh, Saudi Arabia. This study provides critical knowledge for understanding sulfur behavior in crude oil under gamma irradiation, offering potential methods to optimize desulfurization processes. Such advancements not only enhance energy production, but also help mitigate harmful sulfur emissions, supporting global environmental goals. Thank you for joining us on this journey into innovative research on For Science Salah Lotfy channel. Don't forget to like, share, and subscribe to stay updated with the latest scientific discoveries. Hey there, science fans! Welcome back to another exciting episode where we dive deep into the fascinating world of science. Today we're talking about something you might not think about every day: sulfur in crude oil. Yes, that black gooey stuff that powers our cars and heats our homes has a hidden component that can cause quite a stink. You see, crude oil, the stuff we get from under the ground, isn't always the nicest smelling. It's a complex mixture of hydrocarbons and other organic compounds, and one of those compounds is sulfur. And that stinky smell, a big part of that is sulfur. Sulfur is a naturally occurring element found in many types of crude oil, and it can vary in concentration from one oil field to another. Now, sulfur isn't just about a bad smell, it's a significant concern for the environment and human health. When crude oil is refined and burned, sulfur compounds are released into the atmosphere. When it gets burned in engines, it makes something called sulfur dioxide. This gas is a major air pollutant and can have serious consequences for our environment. And sulfur dioxide? It's a big no-no for our planet. It contributes to the formation of fine particulate matter which can penetrate deep into our lungs and cause respiratory problems. This stuff gets into the air and can cause acid rain. Acid rain occurs when sulfur dioxide and nitrogen oxides react with water vapor in the atmosphere, forming sulfuric and nitric acids. Acid rain is bad news for plants, animals, and even buildings. It can damage forests, harm aquatic life in lakes and streams, and erode stone structures. Sulfur dioxide also contributes to something called air pollution. This type of pollution can lead to the formation of smog, which reduces visibility and harms our health. This pollution can make it hard to breathe, especially for people with asthma. It can trigger asthma attacks and worsen other respiratory conditions. So you see, getting rid of sulfur in crude oil is super important for a healthy planet and healthy people. Reducing sulfur emissions can lead to cleaner air, healthier ecosystems, and a better quality of life for everyone. But how do we do that? Well, let's find out. Scientists and engineers are working on innovative methods to remove sulfur from crude oil before it gets burned. Stay tuned to learn more about these exciting advancements. For a long time, we've been trying to get rid of sulfur in crude oil. One of the main ways is something called hydrodesulfurization. It's a big word, but the idea is pretty simple. We use hydrogen, a very common element, to react with the sulfur. This reaction breaks the sulfur away from the oil. Another method is using special materials called catalysts. Catalysts are like helpers in a chemical reaction. They speed up the process of removing sulfur without getting used up themselves. Pretty neat, right? But here's the thing, these traditional methods can be expensive and use a lot of energy. Plus, they don't always get rid of all the sulfur. So, scientists are always looking for new and improved ways to clean up our act. Now let's talk about something really cool, gamma rays. You might have heard of gamma rays from superhero movies or comic books, but in the real world, they're a powerful form of energy that comes from radioactive materials. Don't worry though, we use them safely in controlled environments. Scientists have been experimenting with gamma rays for a while now. They can do some amazing things like killing harmful bacteria in food or sterilizing medical equipment. But could gamma rays also help us remove sulfur from crude oil? That's what some scientists set out to discover. The idea is that gamma rays could break down the sulfur compounds in the oil, making them easier to remove. This could potentially be a more efficient and less energy-intensive way to desulfurize crude oil. Sounds promising, right? Now, let's get into the nitty-gritty of the experiment. This isn't just any experiment, it's a groundbreaking study that could revolutionize the way we handle crude oil. Scientists wanted to test if gamma rays could really make a difference in removing sulfur from crude oil. Sulfur is a major contaminant in crude oil and its removal is crucial for producing cleaner fuels. But first, they needed the right ingredients. The preparation phase is critical because the accuracy of the results depends on the quality and consistency of the samples. They started with two different types of crude oil. This choice wasn't random, it was a strategic decision to understand the broader applicability of their findings. Why two? Well, different crude oils have different properties. Some are more viscous while others are lighter and flow more easily. These differences can affect how sulfur is distributed within the oil. Some are thicker, some are thinner, and they all have different amounts of sulfur. The sulfur content can vary widely, and this variability is a key factor in the experiment. Using two types helped the scientists see if gamma rays work differently on different oils. This comparative approach provided a more comprehensive understanding of the process. Next, they needed a way to zap the oil with gamma rays. This step is crucial because the gamma rays are the primary agent for breaking down the sulfur compounds. For this, they used a special device called a gamma irradiator. This machine is designed to emit controlled doses of gamma radiation, ensuring that the oil is exposed to the right amount of energy. Think of it like a super-powered X-ray machine that uses gamma rays instead of X-rays. Pretty high-tech stuff. The gamma irradiator is a marvel of modern science, capable of precise and powerful radiation delivery. Finally, they needed a way to separate the sulfur from the oil after it was irradiated. This separation is essential to measure the effectiveness of the gamma rays in breaking down the sulfur compounds. To do this, they used a process called distillation. Distillation is a tried and true method for separating different components based on their boiling points. Distillation is like separating the ingredients of a soup. Each component has a unique boiling point, allowing them to be isolated as they evaporate. Each ingredient has a different boiling point, so when you heat the soup, they evaporate at different temperatures. This principle is applied in the lab to separate sulfur from the oil. Similarly, the scientists heated the oil, and the sulfur compounds, now broken down by the gamma rays, boiled off and were collected separately. This final step confirmed the success of the experiment, showcasing the potential of gamma rays in refining crude oil. Section 5. Zapping oil. How we used gamma irradiation. Alright, time to get our zap on. In this section, we delve into the fascinating process of using gamma irradiation to treat crude oil. This method is not only innovative but also highly effective in altering the properties of the oil. The scientists placed samples of each crude oil into special containers that wouldn't block the gamma rays. These containers are designed to ensure that the gamma rays can penetrate the oil without any hindrance, allowing for a thorough treatment. Think of lead vests used in X-ray rooms. We want those gamma rays to reach the oil. Just like how lead vests protect us from X-rays, these containers are designed to let the gamma rays pass through and interact with the oil. They placed these containers inside the gamma irradiator and exposed them to different doses of gamma radiation. The gamma irradiator is a sophisticated piece of equipment that allows for precise control over the radiation dose, ensuring that the oil is treated effectively. It's like giving the oil a little sunbath but with gamma rays instead of sunlight. The gamma rays penetrate the oil, breaking down complex molecules and altering its properties in a controlled manner. They carefully controlled the intensity and duration of the exposure to make sure everything was safe and precise. The control panel of the gamma irradiator allows the scientists to adjust the settings to achieve the desired results without compromising safety. After the oil samples were irradiated, the scientists took them out and analyzed them. This step is crucial as it helps in understanding the changes that have occurred in the oil due to the gamma irradiation. They wanted to see how much of the sulfur had been removed and if the gamma rays had changed the oil in any other way. The analysis involves using advanced analytical equipment to measure the sulfur content and other properties of the oil, providing valuable insights into the effectiveness of the gamma irradiation process. Section 6. The results are in. Did it work? Drumroll, please. The moment of truth. Did the gamma rays work their magic? Well, the scientists found that gamma irradiation actually did reduce the sulfur content in both types of crude oil. That's right, the gamma rays were able to break down those pesky sulfur compounds, making them easier to remove during the distillation process. This is a big deal because it means gamma irradiation could potentially be a viable method for desulfurizing crude oil. However, they also noticed that the effectiveness of gamma irradiation varied depending on the type of crude oil. This means that more research is needed to figure out the optimal conditions for different types of crude oil. Section 7. A promising future gamma power. So, what does this all mean? Well, while more research needs to be done, this study suggests that gamma irradiation could be a valuable tool for the future of oil refining. Imagine a world where we can clean up crude oil more efficiently and with less impact on the environment. Gamma irradiation could potentially lead to cleaner burning fuels, which would mean less air pollution and healthier people. Plus, it could help reduce our reliance on traditional desulfurization methods, which can be expensive and energy-intensive. It's a win-win situation. Section 8. Challenges and next steps. Now, before we get too carried away, it's important to remember that this technology is still in its early stages. There are challenges that need to be addressed before gamma irradiation can be used on a large scale. One of the main challenges is figuring out how to make the process cost-effective. Gamma irradiation can be expensive, so scientists are working on ways to optimize the process and make it more affordable for industrial use. Another challenge is ensuring the safety of the process. Gamma rays are powerful, so it's crucial to have strict safety protocols in place to protect workers and the environment. Section 9. The future of clean fuel. Despite these challenges, the future of gamma irradiation in desulfurization looks bright. Scientists are continuing to research and refine this technology, and with further development, it has the potential to revolutionize the way we refine crude oil. Imagine a world where we can enjoy the benefits of fossil fuels without harming our planet. That's the promise that gamma irradiation holds, and it's a future worth striving for. So, there you have it, science fans. Gamma irradiation, a potential game changer in the fight against sulfur in crude oil. Stay curious, keep exploring, and let's all do our part to create a cleaner, healthier planet. Hey there, science fans. Today we're diving into the world of crude oil and a fascinating process called desulfurization. You see, crude oil, the stuff we pump out of the ground, is full of sulfur. Sulfur is a big no-no when it comes to burning fossil fuels. Why? Because when sulfur-rich oil burns, it releases harmful sulfur dioxide gas into the atmosphere. This gas contributes to acid rain, which damages our environment and our health. So, we need to get rid of the sulfur in crude oil before we refine it into gasoline, diesel, and other fuels. This is where desulfurization comes in. It's a crucial step in making our energy sources cleaner and more sustainable. We're talking about the future of our planet here, people. Traditionally, desulfurization involves using expensive and complex chemical processes. But what if I told you there's a new kid on the block? A powerful force that can tackle sulfur with amazing efficiency. Get ready to be amazed by the power of gamma radiation. Gamma radiation, as you might know, is a high-energy form of electromagnetic radiation. It's the same type of radiation used in X-rays, but even more powerful. Now, you might be thinking, gamma radiation isn't that dangerous? And you'd be right to be cautious. Gamma radiation can be harmful in large doses. But scientists have discovered a way to harness its power safely and effectively for desulfurization. Here's the gist. When gamma rays hit crude oil, they interact with the sulfur molecules, breaking them down into less harmful substances. It's like using a super-powered beam to zap away the sulfur. This innovative approach has the potential to revolutionize the way we clean our fuels, making the process more efficient and environmentally friendly. But how well does gamma radiation really work in removing sulfur from crude oil? Let's dive into the research and find out. Scientists have been hard at work, putting gamma radiation to the test on different types of Arabian crude oils. And guess what? The results are in, and they're exciting. Studies have shown that gamma radiation can effectively remove a significant portion of sulfur from various crude oil samples. But here's the thing, not all crude oils are created equal. Some are naturally lower in sulfur, while others are loaded with the stuff. The good news is that gamma radiation seems to be effective across the board. However, the efficiency of sulfur removal can vary depending on the specific type of crude oil and the intensity of the gamma radiation used. In some cases, researchers have observed sulfur removal efficiencies of up to 70% or even higher. That's a big deal, people. To understand why gamma radiation works so well, we need to zoom in on the molecular level. Let's put on our chemistry hats and explore how gamma rays interact with crude oil using a technique called FTIR spectroscopy. FTIR spectroscopy, or Fourier transform infrared spectroscopy, is a powerful tool that allows scientists to analyze the chemical composition of materials. It's like taking a fingerprint of a molecule. When gamma rays bombard crude oil, they cause all sorts of interesting chemical reactions. FTIR spectroscopy helps us identify these changes by analyzing how molecules absorb infrared light. By comparing the FTIR spectra of crude oil before and after gamma irradiation, researchers can pinpoint exactly how the sulfur molecules are being transformed. These analyses have revealed that gamma radiation breaks down sulfur-containing compounds in crude oil into smaller, less harmful molecules. Some of these byproducts can be easily removed from the oil, resulting in a cleaner fuel. But wait, there's more. FTIR spectroscopy also helps us assess the stability of crude oil under gamma irradiation. Let's explore this further. Section 5. Stability under the gamma rays, analyzing crude oil properties. Remember how I said gamma radiation is powerful stuff? Well, when you're dealing with powerful forces, it's essential to make sure you're not causing any unwanted side effects. In the case of crude oil, we need to be certain that gamma radiation isn't breaking down the oil itself into unusable components. Thankfully, FTIR spectroscopy comes to the rescue once again. By analyzing the FTIR spectra, researchers can determine if gamma irradiation is altering the fundamental properties of the crude oil. They look for changes in the oil's viscosity, boiling point, and other important characteristics. The good news is that studies have shown that gamma radiation, when applied appropriately, doesn't significantly degrade the quality of the crude oil. That means we can use this powerful tool for desulfurization without compromising the oil's refining potential. Now let's explore some ways to make this process even better. Section 6. Boosting efficiency, oxidizers, catalysts, and temperature. Scientists are always looking for ways to improve existing technologies, and gamma desulfurization is no exception. One promising avenue for boosting the efficiency of this process is by combining gamma radiation with other treatment methods. For instance, researchers are exploring the use of oxidizers, like hydrogen peroxide, which can help break down sulfur compounds more effectively. Another approach involves using catalysts, which are materials that can speed up chemical reactions without being consumed in the process. Think of catalysts like a helping hand for gamma radiation, making the desulfurization process even more efficient. Furthermore, studies have shown that conducting the gamma irradiation process at elevated temperatures can also enhance sulfur removal. It's like giving the whole system a bit of a thermal boost. By fine-tuning these parameters, scientists are constantly pushing the boundaries of gamma desulfurization, making it an even more attractive option for cleaner fuel production. Section 7. A cleaner future implications for the energy industry. The development of gamma radiation as a desulfurization technique has far-reaching implications for the energy industry. Imagine a world where we can produce cleaner-burning fuels with reduced sulfur content, leading to lower emissions and a healthier environment. This technology has the potential to revolutionize crude oil refineries, making them more efficient, cost-effective, and environmentally friendly. By adopting gamma desulfurization, we can significantly reduce the release of harmful sulfur dioxide into the atmosphere, mitigating the effects of acid rain and improving air quality. Moreover, gamma radiation offers a cleaner alternative to traditional desulfurization methods, which often involve using harsh chemicals and generate hazardous waste products. This shift towards greener technologies aligns with the global push for sustainable energy solutions. But the journey doesn't end there. There's still much more to explore and discover in the realm of gamma desulfurization. Section 8. Beyond the Horizon. Future Directions for Gamma Desulfurization. As with any emerging technology, there's always room for improvement and innovation in gamma desulfurization. Scientists are continuously exploring new avenues to enhance the efficiency and applicability of this promising technique. One area of focus is the development of more compact and cost-effective gamma radiation sources. This would make the technology more accessible to a wider range of refineries, including smaller facilities. Another exciting research direction involves exploring the synergistic effects of combining gamma radiation with other advanced oxidation processes, such as ultrasound or electron beam treatment. These hybrid approaches could lead to even higher desulfurization efficiencies and open up new possibilities for tackling other contaminants in crude oil. Furthermore, researchers are keen on optimizing the irradiation parameters, such as dose rate, temperature, and pressure, to maximize sulfur removal while minimizing any potential impact on the crude oil's properties. The future of gamma desulfurization is bright, and with continued research and development, this technology has the potential to play a pivotal role in shaping a cleaner and more sustainable energy landscape. Section 9. Conclusion: a powerful tool for a sustainable future. Gamma radiation, once feared for its potential hazards, is emerging as a powerful tool for good in the realm of crude oil desulfurization. By harnessing the power of these high-energy rays, we can effectively remove sulfur from crude oil, paving the way for cleaner-burning fuels and a healthier environment. This innovative technology offers a glimpse into a future where we can meet our energy needs while minimizing our impact on the planet. With continued research and development, gamma desulfurization has the potential to revolutionize the energy industry and contribute to a more sustainable future for all. So there you have it, science fans. The next time you hear about gamma radiation, remember its potential to not only unlock the secrets of the universe, but also to clean up our act here on Earth. Stay curious.
And that brings us to the end of this episode. We hope you enjoyed this deep dive into the fascinating world of scientific discovery on For Science Salah Lotfy channel. Stay tuned for more exciting episodes where we explore the wonders of science. We extend our heartfelt gratitude to the brilliant researchers who dedicated their time and effort, whose exceptional work made this study possible. Your passion and commitment continue to inspire us all. Our sincere thanks to Professor Dr. Ahmed Basfar, currently at the King Saud University College of Engineering, Mechanical Engineering Department. His groundbreaking research in mechanical engineering has paved the way for numerous advancements in the field. Dr. Basfar's dedication to innovation and education has inspired countless students and professionals alike. His work not only contributes to the academic community, but also has practical applications that benefit industries worldwide, and a leading expert in nuclear and radiation engineering. Dr. Basfar's expertise in this specialized area has been instrumental in developing safer and more efficient technologies. His research has significantly impacted the way we understand and utilize nuclear energy, ensuring that it is harnessed responsibly and sustainably. His contributions have been recognized globally, earning him numerous accolades and respect from his peers. Additionally, we applaud Professor Dr. Yasser Soliman from the Radiation Protection and Dosimetry Department, National Center for Radiation Research and Technology, Egyptian Atomic Energy Authority. Dr. Soliman's work in radiation protection is crucial for the safety of both workers and the public. His research in dosimetry has led to better monitoring and control of radiation exposure, ensuring that safety standards are met and maintained. His efforts have made significant strides in protecting people from the potential hazards of radiation. Lastly, we commend Professor Dr. Turki S. Alkhuraiji from the King Abdulaziz City for Science and Technology, Nuclear Science Research Institute and the National Center for Irradiation Technology in Riyadh, Saudi Arabia. Dr. Alkhuraiji's research in nuclear science and irradiation technology has been groundbreaking. His work has led to advancements in the field that have practical applications in medicine, agriculture, and industry. His dedication to research and development has not only advanced scientific knowledge but also contributed to the betterment of society. We are grateful for his tireless efforts and the positive impact of his work. The tireless efforts and innovative approach to studying sulfur transfer in Arabian crude oils under gamma irradiation have led to groundbreaking discoveries. These dedicated scientists have meticulously analyzed the complex interactions and chemical reactions that occur during the irradiation process. Their research has provided invaluable insights into this critical area of energy research, shedding light on previously unknown mechanisms. The data collected has the potential to revolutionize how we understand and manage sulfur content in crude oils. This is a testament to their expertise and commitment to scientific advancement. Their work not only advances our knowledge but also paves the way for more efficient and environmentally friendly energy solutions in the future. To all our dedicated viewers, thank you for joining us. Your support fuels our mission to bring you the most important scientific research from all disciplines and all corners of the world. Stay tuned for more insightful episodes. Here at For Science Salah Lotfy channel, we are committed to celebrating scientific excellence and sharing knowledge that shapes our future. Don't forget to like, share and subscribe to For Science Salah Lotfy channel. See you in the next episode where more groundbreaking discoveries await.